Hey there, everybody. Let's go ahead and get our materials and get started on some reviews, some awesome stuff. I love this stuff. Okay, these are coordinate planes, okay? But hey, wait, go get your packets. We're going to start at 8C. So go ahead and look at standard 8C. It's in that packet that you got from the school with your notebook. All right. Okay, so this is the positive. You'll learn more about this in junior high, but this is the positive quadrant one of a coordinate plane. And you're going to be doing a lot of graphing equations when you get to junior high. But the fun part about elementary is we're just getting started with starting at the origin. The origin of all things is the beginning. So when you are working on your coordinate plane, you look at your points and you start at 0, 0. And let's see, this is called an ordered pair. It almost looks like a little face. I could put a little smiley face right under that. And this is called the origin. It's at 0, 0. So what that means is your X and your Y will always be in that order. When we look at input-output tables, this is what you're going to be doing is graphing relationships. All right, but we'll get started remembering how to graph first and place your ordered pairs, and then we will get into 4C, and then we'll start looking at those relationships with the input-output tables and how to graph those. All right, so let's look at these ordered pairs. Remember, when we look at our X and Y, our ordered pairs, we always go over, then we go up. Now, again, in junior high, you'll be going over also in the opposite direction because it'll be negative numbers. And then you might not be going up, you might be going down, again, because you will have negative numbers. But in 5th grade, we're only looking at positive values that are greater than 0. So you will be going either to the right, over, and then up. You always do your X axis and then your Y axis. All right. So let's look at what this says. That was just some review. It says on the grid below, Shing will place point X at 7, 1. Okay, so remember, this is an ordered pair. We're always going to go over X and then up Y. So again, in junior high, it could be over and then down. Okay, so let's check this out. We're going to go over 7 along the X-axis. Go over 7, and then we're going to go up 1. All right, so we're going to place our point. Make sure you draw that. And it's not huge. You're not going to draw some big old huge dot right there. It's just small, like these down below. All right, and we're going to write X. It's almost like a treasure map. All right, and then we're going to put point Z at 7, 9. Okay, again, that's your X and that's your Y. So we're going to go over 7 and up, and you'll follow. Don't draw the lines. I see a lot of kids doing that. You're going to draw your lines. Don't do that. You're just going to go over 7 and then just follow along. Just hover your pencil over and then go up to 9. All right, you don't want all those lines all over the place, okay? All right, so there's X and there is Z. Best thing to do would be to go ahead and practice labeling, okay? So this would be 7, 1. Okay, that's showing your proof where you placed your point. And then this is 7, 9. Okay, good job. So it says, if Shing places point Y halfway between the points X and Z, halfway, all right, which ordered pair will describe the location of point Y? So let's go ahead and look at what halfway means. All right, so half of this. You could just kind of look and see about where half between these 2 points would be. I'm looking right here, so let's kind of prove that. I think it's here. Let's count how many lines or points we go up and then how many points we go down to see if they match. So let's go up. 1, 2, 3, 4. That goes 4 up. Let's start here and go down. 1, 2, 3, 4. So that's exactly halfway. I believe this is exactly where Y would be. So let's go ahead and label. How would we get to Y from our origin? we'd go over 7 and up 5. So if you'll notice right here, again, do not draw those lines. Don't trace it over. Just kind of hover your pencil up. All right. So this would be 0.75. All right. That would be your ordered pair. And if you'll notice, that's what this is right here. Remember, we're always going over your X and then you're traveling on your Y axis. Okay? Good job. Let's look at number 2. It says, Callista, place the points on the grids below. It says, which table represents the points on the coordinate grid? Now, these look a little bit different than what we've seen because we see fractions, but is it possible to have values between whole numbers? Absolutely. So before we start looking at these answers, I think we should evaluate the scale that's going across on the x-axis and the y-axis. Okay, so let's start thinking about what these lines in between might represent. So again, starting at our origin, which is 0, 0, that's where you'll always start on your coordinate planes, quadrant 1. Okay, so let's see, what's halfway? What is this line then? What's halfway between 0 and 1? It's 1/2. So what would be between 1 and 2? It'd not just be half, it'd be 1 and a half. So this accordingly would be 2 and 1/2. This would be 3 and 1/2, 4 and 1/2. And do you think that it would be the same going up on the y-axis? Yes, it would be. Halfway between 0 and 1 is 1/2. This would be 1 and 1/2. This would be 2 and 1/2. I would challenge you to go ahead and label these. That will get you in the habit of proving your work and and also making certain that you're figuring out the correct value between. Okay, so let's find our first point and we're going to label them. All right, so again, we always go over X and then we travel along the Y axis. Okay, so our first point, we go over to 1.5. So let's go ahead and start labeling 1 and 1/2. And then we go up 1. Okay, let's label our second point. That would be over 2.5. And up 2. All right. Okay, so go ahead and pause the video and label the next 2 points and then turn it back on to play and see if you've plotted these correctly, okay? Pause that video, label, and come back. Okay, so this one is going to be over 3.5 along the x-axis first, and then up 3. And then this will be over 4.5 and up 4. Okay. So let's go ahead, now that we've labeled and proven our work, it's going to be easier, I believe, to find which table represents the points on the grid because you've already labeled those, okay? It should be exactly like this listed in a table. And remember, this is going X, Y, so it should be in the order of your ordered pairs. So that makes it easy. All right, so let's look at all of our X's. We know our X's are these values right here. These are all your X's and they are all mixed numbers. So it can't be this one. We know that it's not that because all of our X's in this table are whole numbers. So if you look at these are all 1.5. They match. You can also do a finger check. You can look and match 1.5, 2.5, 3.5, and 4.5. This is looking good so far just by looking at our X values. Then this one also looks very good just by looking at our X values. But let's look at J. If you'll notice, J starts off okay, 1.5, but then it shows that the X value for the second ordered pair is 2, and that's not the case. So this whole table is also incorrect. So now all you have to do is look at your Y values, and you probably already figured it out just because you showed your work really, really well that G is going to be our answer because look at your Y values. They're exactly, see, this is your ordered pair right here. 1.5, 1, and that's what this is right here. This is 2.5, 2. Here's your ordered pair. Right here. Here's your ordered pair. The next one. And then this is your ordered pair. This is exactly what we're doing when we're graphing our equations, our input-output tables, whatever this relationship is, we can pick this up and graph it on a coordinate grid. All right? Great job. Great job. Okay, we only have 4 questions on this page. All right, so Lisa will place a point at 2, 0. Okay, so here is a direction. We're placing a point at 2, 0. Remember, your x is first and then your y. So over 2 and up 0. Now, what does it mean when you go up 0? That means you don't move. You're going to stay. You're going over 2 and up nothing. You're just going to rest on that line. So that's a point right there. And a point at 8, 6. Again, we're going on along the x-axis first from the origin, which is 0, 0, over 8 and up 6. Again, please do not trace those lines. That is not going to be helpful for you. So here's 8, 6, and here is 2, 0. All right, so let's see. We've already plotted what we're looking for. It says then she'll draw a straight line that connects the 2 points. So my challenge to you would be to get something. If you don't have a ruler, get something like a business card or just something that's straight, a piece of paper, maybe part of your journal, something, and just make sure that your edge goes right there between the middle or in the middle of those 2 points, okay? And you'll do a lot of this in junior high. You'll have a nice, beautiful straight line there, okay? So let's see what's going on. It says, which ordered pair is located on the line? So all we've done is we've followed directions, we've drawn, and let's look. We're going to prove it. Okay, let's see if I'm use a different color. 5, 3. Let's see. 1, 2, 3. That is on that line. Check mark. Let's see about B. 4, 6. Let's go over 4 and up 6. No. Here's A. Always label. B is not going to be on that line. Let's look at C. Over 7 and up 1, 2, 3, 4. It's close, but it's not quite. If I had said 7, 5, that would have been on the line, but 7, 4 is not. Okay, let's look at D. 1, 3. Oops, sorry. This is D. D does not land on the line, but that gives you some extra practice when you look at all those points and plot those. Okay, so not on the line. Okay, or is on the line, excuse me. Now I'm going to get a third color. It says which ordered pair is not located on the line. So we're going to plot all 4 of these points and see which one is not on the line. So 3 of these probably will be, 1 of them will not. Okay, let's look at 6, 4. We're going to go over 6 and up 1, 2, 3, 4. A, or, ooh, golly. F is on the line. That's not what we're looking for because F is on the line. Look at G, 4, 2, over 4. That's 1, 2. This is G. This is on the line. Let's look at H. 5, 3. 1, 2, 3. That is the same point that A was. This is H. Okay, remember we had that one right here. Hoping that it's 5, 7. Otherwise, we've done something wrong. Okay, so over 5 and up 7. 1, 2, 3, 4, 5, 6, 7. This is a winner. This one's not on the line. Great job. I'm sure you got that one also. Okay, so as we get into the next page, anything that's on this line, you'll find out is going to have a rule that belongs to that. There is an actual mathematic rule that all of these points would follow. All right, we'll talk about that a little bit more when we get to input-output tables. Okay, So number 2 says Gabriel. Oh, Gabriel. Gabriel drew a hexagon. Now remember, a hexagon has 6 sides. It's a polygon with 6 sides, no curves, completely closed on the grid below. So we have 1, 2, 3, 4, 5, 6. That is in fact a hexagon. It says which ordered pair represents a point that is inside the perimeter of the hexagon. Now, lucky for us, we've been studying about perimeter this week. So that is the outside line. So we're looking for something that is inside this hexagon. Okay, so let's go ahead and see which one of these ordered pairs is inside this hexagon. Okay, so 1 and 3/4. Can we have fourths on our grid? Absolutely. Let's go ahead and start labeling. I think that might be a really good idea. Okay, so let's look between 0 and 1 whole. We have several lines between here and 1 whole. So we have how many parts? 1, 2, 3, 4 parts. So those, let's go back to fractions. Those are fourths. So this would be 1/4. This would be 2/4 or 1/2. This would be 3/4 and 1 whole. So that would mean that this is 1 and 2/4, 1/2. Remember, in 5th grade, we need to make sure all of our fractions have been simplified. This would be 1 and 3/4, 2. This would be 2 and 1/4. All right, so the same thing we could do up the y-axis. Why don't you go ahead and take a second and label your y-axis. Okay, so mine's already labeled now. So let's go ahead and get to it. A is at 1 and 3/4. 1. Now remember, this, just because it sounds strange, it's not. We're just going to go over 1 and 3/4. Here's 1 and 3/4, and we're going to go up 1. Okay, so that is not it because it is not inside the perimeter. Okay, so not it. Okay, let's look at B. We have 1 and 1/2. So again, they're expecting us to have all of our fractions simplified. So that's why I made sure to note that 1 and 1/2 is the same as 1 and 2/4, but they have this as halves instead of fourths. So 1 and 1/2, and then 1 and 3/4. If you labeled your y-axis, you can go all the way up to 1 and 3/4. That is inside. So let's kind of put a dot right beside that. This is point B. All right, so C is 1 and 3/4, and then 1 and 3/4. Right next door. Okay, here is C, and as you can tell, that is outside the perimeter. So it can't be C. And then let's look at D. There's the proper correction. You go over 3/4 and up 1 and 3/4. It's just like this one over here. It's right outside that line. So here's D. That is not going to work. I hope that you came up with B. B is correct. It is inside the perimeter of the hexagon. Okay, so now, oh gosh, wait, they've changed the game. They have now put these values as fractions. Pardon me, as decimal numbers instead of fractions. So we kind of need to reframe our thinking, right? 25/100ths is, if we have 25/100ths, let's think of quarters, all right? Let's review fractions and decimals real quick. If we think of quarters, 25 cents is a quarter. And how many quarters do you need to make $1? You need 4 of those. So this would be 1/4. If we simplify this, 25 is a fraction, or excuse me, a factor of 25. And 25 is a factor of 100. So we could divide. Let's go back to simplifying. 25 divided by 25 is 1, and 100 divided by 25 is 4. So we can think of these as fractions. Absolutely. 75/100ths is, if you think of 75 cents, you have 3/4, and you'd only need 1 more, so you'd have 3/4 of what you need in quarters. And then 5/10 is the same as 50/100ths. If you have 50 cents, you have 2/4 out of $1 whole. That would be 1/2 or $1. Okay, so let's go ahead and think about that really carefully. We could go ahead and relabel this if we wanted to. Make it a little easier. Okay, so if we look at this, this would be 25 cents, 50 cents, $1.50, $1.75, $2.25. If you think about it in terms of money, that's exactly what that would look like. And let's go ahead and label up the y-axis. We have 25 cents, 50 hundredths, 5 hundredths, 1 whole, 1 and 25 hundredths, 1 and 50 hundredths, 1 tenths, 1 and 75 hundredths, 1 and 2 and 25 hundredths. Okay, so now let's look at this in a different way in terms of decimals. Okay, the first pair says which ordered pair represents a point that is outside the perimeter of the hexagon, okay? And then 1 and 25 hundredths. We go over 1 and up 1 and 25 hundredths. That's all the way up here. Here's F. It's inside. Inside. So that's not the answer. J, I keep saying J for G. Good grief. 1 and 25 hundredths. We go over and then up 75 hundredths. Oh, here it is, right here. Here is G. That is also inside. Let's look at H. We have 75 hundredths and then up 1 whole. Ooh, that looks like it might be the 1. Let's label that. And let's go ahead and plot J because we need to make sure that we were correct. All right, so 1 and 5 tenths or 50 hundredths, you could say it either way. And then up 1 and 5 tenths or 50 hundredths. No, that is a J. Okay, so we were correct. This is inside. So it has to be H, which is the only point that we plotted that was outside the hexagon. Okay, friends, one more page. There's only 2 problems. We'll have a little bit to discuss, but not too much. You're welcome to fast forward at any time. But I just want you to make sure you're reviewing these things because it is going to be important for you as you move on to junior high. Okay, what we're doing, this looks just like what we did in the previous part of the video, but this time we're going to be talking about an actual equation that shows or illustrates why we have, or this line actually illustrates the equation that it's describing. So we're going to look at, it says which table shows 4 other points that satisfy the equation y equals x plus 1 and 1/2. What on earth does that mean? What it means, let's see what this says. Whatever x is, we're going to add 1 1/2 to it, and that will equal y. So just because it says y equals first, that's what you're going to see a whole lot. We could flip both of these and say, okay, well, x plus 1 and 1/2 equals y. So we could always, if this makes more sense to you, you can always rewrite it that way. Remember that equal sign is just a place where you can flip something over. It just means that whatever is on this side is equal to whatever is on this side. And you could always rearrange that to say y equals x plus 1 1/2. It's the same thing. Okay, so let's go ahead and look at what these points mean. Again, like in our previous part of the video, we always start on our coordinate grid at the origin, which is 0, 0. Very important part of the coordinate grid is the origin. Remember on the grid. Okay. All of our x's start with whole numbers. You'll notice this point here goes over 1. This point here is x is 2. We're always going over a whole number each time. But if you notice going up on our y-axis, all of our points are halfway between the whole numbers. Each one of our lines goes up by 1 whole. So this is going to be a half. So let's kind of think about what the next points would be. If you'll notice, this does form a line. You can just connect the dots and see that a line will be formed by these, okay? This is called a linear equation. It forms a line. There's a rule that's attached to that, okay? So even if we look at these charts and we see, or at these tables, and we see what's going on with our x's and y's, you'll notice that this particular chart shows that all of our y's are whole numbers. So if you want, if this looks really overwhelming, you could already cross that off as an answer choice because there are no half values and all of these y values have half. So if we want, you should go ahead and label this is 1, and what does this go up? It goes between 2 and 3, so it's going to have to be 2.5. Okay, so that's going to be our value for that point. This will be, and I'll write it on this side of the line because of room, this will be 2, and then it goes up 3.5. And this goes up, or excuse me, over 3 and up 4.5. This one goes over 4 and up 5.5. You can see that it's a whole number and then a whole number and a half. So it might be easy for you to find these next few points. And if you actually drew the line like I did, you'll notice that your halves are already there. Ooh, and I guess I could have extended that just a little bit more. And that would be our next 4 points. You'll notice it's going to be 5, 6, 7, and 8. All of these say 5, 6. Ooh, no, they don't. Look. Okay, the next 4 points, these are all of our x values are going up by 1 whole. So why wouldn't these go up 5, 6, 7, 8? Let's look and see if these x values would even work. Trace this on a line or on a straight edge, you would notice that those points follow right along with this pattern. Patterns are very important in math. And you'll notice this goes over 5, over 6, over 7, and over 8. Those are the next 4 points. It doesn't skip. Okay, so let's see what's going on if we just use math. Okay, so if we have 5 and we add 1 1/2 to it, wouldn't that be 6.5? Yes. If we have 6 and we add 1 1/2 to it, wouldn't that be 7 1/2? Yes, it would. Again, we're going to go ahead and make sure that we always write our rules and solve them all the way throughout the table. And this actually does work out. Should we go ahead and see what's going on with this table? These two. Yes, yes, always prove your work. You know, interestingly about this, this is an increasing value. We are not subtracting. Whatever x is, we're adding to it to get y. So in this case, the number is smaller. Each one of these values is less than our x values. So this, just by thinking of what makes sense, that one would not work at all because it's decreasing by 1/2. Now, if we look at this, this table shows an increase, but is it an increase of 1 whole and a half? Well, if this is 6 and then this is 6.5, aren't we only going up by a half in each of these values? We're not going up by 1 1/2. So I hope that made sense to y'all. I know I'm kind of going through it a little quick, but this video is kind of long, so I just really want y'all to think about it. Go ahead and rewind it, play it again, and see what you think. But if you just think about what makes sense with adding 1 whole and a half, this one is going to be the only one that works. And if you trace the line, you can actually see where these points would fall, and you could match those up with the numbers. Y'all, there's always more than one way to work a problem, okay? All right, last one, guys. Thanks for staying with me. It says Deborah is going, now this is fun. This is my favorite part. All right, this is when we find our values in the input-output table by a rule, and then we use this to find which table actually plotted the points correctly. And if you look at these, they all form a line. This is a steep line. this was a hill, it'd be a very steep hill. This is going to form a line. If you just follow the dots, they're all going to show an actual equation with a rule. It's called a linear equation. But only one of these charts is going to show the rule for this. Okay, so it says Deborah's going to complete the input-output table below, then graph the ordered pairs that it generates. Okay, so again, don't let this look, this is not crazy, but you need to understand how to decode a math problem. Okay, so what this means, and I've said this earlier in other videos, and also we've all said it in class, whenever you see a number next to a letter, what that means is we're multiplying this number times whatever this value is. If we know our x values, then we can go ahead and multiply this. And whatever this is, it equals y. So we can just flip this over. We could always say 5/10 times whatever x is going to give us our y value. We could rewrite it so that it makes a little more sense to you, but it still means the same thing. So let's write our rule. Okay, so whatever x is, we're going to multiply times 0.5 or 5/10. All right, so we can say times by using parentheses as well. So there are so many ways to represent multiplication in math. Once you finally figure out all the ways, it's going to be it's like learning a language, guys. Numbers and symbols, learning that language is very important. So let's see what we have here. Okay, so what is 1 times 5/10? Well, any number times 1 is that number. So if that's the case, 5/10 times 1 is 5/10. It keeps that value, right? Okay, so remember, even with decimals, you just multiply it as usual and then place your decimal. So 5 times 2 is 10. And how many decimal places are in that multiplication? 1. So we're going to move from the right to the left 1 time. And so 2 groups of 5/10, 2 groups of halves. 2 halves equals 1 whole. So look at that, equals 1 whole. Okay, 5 times 3 is 15, but we have a place value there we have to represent with our decimals, so it'd be 1 and a half, 1 and 5/10. 5 times 4 is 20, but we go back 1 place value. We move that decimal back to the left to show our place value. And throughout the year as we placed our decimals, multiplying decimals. Okay, so let's look. These are our ordered pairs. So let's see. It would be our x value, which is 1, and then our y value, which is 5/10. Here's your x value. We just did something with it, okay? That's all we did, is we did something with x in order to get y. And what did we do? We multiplied 1. This is our rule. We're multiplying all of our x values by 5/10. All right, that's all we did was we multiplied each one of our x values times 5/10. So what is our x value? It's 1. And what is our result? It's 5/10. So we're going to go over 1. Uh-oh, this went over 1 or over 0.5 and up 1. And that's the opposite of what we're looking for. This is not going to be correct. We're looking for our x value to be 1 whole. Okay, so here's where we started out over again. Let's see if this one works. Over 1, and this is up 1/2. So over 1 and up 0.5. And doesn't that match that? Let's see if the next one works. Over 2 and up 1 whole. Yes, over 1, over 2 and up. Okay, over 3 and up 1.5. 1.5. Absolutely matching. And then this one says we're supposed to go over 4 and up 2. That is exactly right. Over 4 2. This one looks like it's going to work, but let's go ahead and see what's wrong with these two. Okay, remember, this is where you'll have to make sure you're looking at your x values. You could highlight those. X is this number. This is just what we did with x to get y. These are the values that we're plotting on our coordinate grid. Okay, so this one goes over 1, fabulous, but this goes up 1. This is 1, 1. This is 2, 2. This is 3. This is making all kinds of crazy mistakes. When you get in a hurry, look what happens. Over 3 and up 2. And this is over 4 and up 2.5. Not great, Wilson. All right, I corrected that. Over 1, 1, 2, 1.5. This is like it's kind of flipped a little bit. This is not going to work. It does follow a rule, but it's not the rule that we were using. And then here, this one was what I was trying to write on this one. I don't know why I was doing that, but here's 1, 1. This would be 1.5, 2. Okay. And this one would be over 2 and up 3. And this is over 2.5. That does not match what we're doing here at all, does it? No. All right, so we did find our answer. Hope I didn't confuse you on that last one. I guess my brain's getting a little silly. So I hope you enjoyed that. I hope it taught you something, maybe reminded you of some things. And thanks for watching.